All right, last video for this chapter. This one wasn't a crazy because the urinary system tends to be a little bit more physio. There's not too many moving parts, but we're going to still treat it as very important because it is. We're going to finish up with all the other parts of the urinary system. You'll notice the first two videos put a heavy emphasis on the kidneys, both macroscopic and microscopic. Because the kidneys really are the workhorse doing the tough stuff for the urinary system. But it's not alone, right? You don't just have kidneys making urine and then end of story. We have the rest of the urinary system. And so we're going to talk about everything that comes after the kidneys, namely the ureters, the urinary bladder, and the urethra. We'll talk about their location, structure, histology, and functions. We'll compare and contrast male and female urethras because there is a difference. And then we'll talk a little bit about the micturition reflex, also known as you needing to pee. So let's get into the urinary tract. Why do we have the rest of the urinary system, basically? Because all that urine being made in the kidneys has to go somewhere, right? And so really the big thing with the urinary tract is transport and store. Transport the urine away from the kidneys, store it in an appropriate location until you can do the last thing, which is excrete it out, meaning store it until you can go urinate in an appropriate location. And we have three organs for this. We have the ureters, we have the urinary bladder, and the urethra. So let's talk about the ureters first. Now these are going to be retroperitoneal, meaning again they're going to be behind the peritoneal area. You have one per kidney, and since most people have two kidneys, you have two ureters as well. Both of these are going to link up with the urinary bladder. They are continuous with the renal pelvis, meaning as the renal pelvis comes down, it very seamlessly becomes the ureter. We're going to use peristalsis, remember that term, that rhythmic muscle contraction to help move urine down to the urinary bladder. So we're not just relying on gravity. And we have a sphincter to get us into the urinary bladder as well. And so this is going to prevent a reflux of urine from coming from the bladder up into the ureter. So if you were to hold it, you were to hold your urine for a long time and your bladder were to fill, the sphincter is going to prevent your bladder from emptying upwards instead of downwards, right? That's what that sphincter is for. So you think about it, you're like, yeah, that's really important, right? This is really important. If we look at the histology of the ureter, we have the mucosa with transitional epithelium and goblet cells for mucus for ease of movement. We have longitudinal and circular smooth muscles for peristalsis. So we see some similarity in the structure, kind of similar to what we saw with the GI tract, right? Very similar in that aspect. Even with the adventitia, right, which is going to have collagen and fats that'll help anchor the ureter so it's not just free floating wherever inside the abdominal cavity. And so this is our ureter. If we were to take a cross section, we're looking at the lumen inside. This is where urine would transport through. We see the smooth muscle layer and then the adventitia towards the outside. And again, this is to help transport that urine. Getting down to the urinary bladder, it's going to be partially retroperitoneal. The peritoneum is going to cover the top of it, like this little dome side of it on the top. We are going to get the urine from the two ureters. So if we are going from two kidneys, two ureters to one single bladder, and we have a mucosa with a transitional epithelium. This transitional epithelium is going to allow for stretching, right? So the epithelial cells have the ability to change shape in response to the bladder filling, right? We also have muscles called detrusor muscles that are going to crisscross, and this is what's going to be what allows us to force urine out, so we can make ourselves pee, right? Basically, we can empty the bladder fully, and it'll also distend as urine accumulates. And this distension is important because this is going to be what's going to help tell our nervous system, hey, the bladder is full. But we're not there yet. So let's go ahead and take a look at the urinary bladder here. So we see the peritoneum is this kind of clear looking structure coming over the top. We see the ureters, they actually come down, back, and behind, and so their openings to the ureters are right here, these little dots you see. We see the detrusor muscle, right, crisscrossing in different directions. On the very inside, it's too thin to see here, but we can see it here in the micrograph, is the transitional epithelium that can change shape in response to stretching. We then have two sphincters, the internal urethral sphincter and the external urethral sphincter. The internal urethral sphincter is involuntary, but the external is voluntary. And if you think about it, that makes sense because you can hold it, right? You can feel the urge, the need to urinate without actually just going, right? You can hold it until you get to an appropriate location. So we do have some conscious voluntary control over this, mainly at the external urethral sphincter. Now, I mentioned the innervation stuff. We'll get to that when we talk about the micturition reflex, which again is the need and action of urinating. So we'll hold off on that for now and save that towards the end of this video. But let's go ahead and talk about the urethra. It starts as a trigone of the bladder. Now I'm going to go back to the other slide so I can point this out visually. But we see how it kind of goes whoop, right here, like from a triangle, then into a canal. That's what we mean there. The upper region is going to have transitional epithelium, kind of like the bladder. And then the lower region is going to become non-keratinized stratified squamous epithelium. We have the internal and the external urinary sphincters. Again, the internal one is superior, it's closer to the bladder, it's made of smooth muscle, so it's involuntary. You do not have conscious control over your internal urinary sphincter, but you do have control over your external one, which is inferior. This is with skeletal muscle, this is voluntary. And you choose to go and urinate when the time is appropriate, right? You can feel the need to urinate without actively peeing in that moment. You can go and hold it until you get to an appropriate location. Now, when we look at the male and female urethras, up until this point, pretty much everything we've talked about has been pretty much the same, right, in terms of male versus female bodies. But this is one place where the two sexes diverge from each other, the urethra. And so if we look at the male urethra, we're looking about 20 centimeters in length, because this is actually going to be starting all the way up in the prostate, and it's going to move all the way down, right, through the penis, right? So we have the pre-prostatic, which is right before the prostate, the prostatic, which is going to be, it's the section that passes through the prostate, the membranous, and then the spongy or penile is going to run through the penis itself. So there's a lot more going on here. There's a longer pathway for urine to take. On the female side, it's only 4 centimeters. So we have 20% of the length, so much, much smaller. We find the opening of the urethra between the clitoris and the vagina. So this is another important thing too. Another big difference. The male urethra is a shared structure between the urinary and the reproductive systems. But in the female reproductive system, the female urethra has no overlap with the reproductive system. So you think about how, like, openings, the vaginal opening and the urethral opening are completely separate in the female body, right, in the body that contains a vagina. Because of this length, though, and because of other actions like the fact that the vagina is a copulatory organ, meaning it's used for sexual intercourse, the female urethra is exposed to more urinary tract infections. That shorter length and its neighbors, so to speak, and what those neighbors do, right, means that bacteria from the vaginal canal, bacteria that is introduced through sexual intercourse can sometimes make their way into the urethra, and they can start to colonize that urethra. This is one of the reasons why you hear, if you haven't, this will be new, but this is one of the reasons why you hear the importance of urinating after intercourse to help flush out anything that may have moved and made its way into the urethra. So here's the difference, right? So we have the female female urethra up top, male urethra down below. We see that here's the bladder, and then that's it with the urethra. Bam! Super short. But on the male side, right, we go through, you have right before that prostate, we have going through the prostate, we have them coming through the tissue here, and then all the way through down to the tip of the penis. It's a much longer urethra. All right, so now let's go ahead and get into the micturition reflex. This is, again, just urination. This is the reflex that allows you to urinate. It's what makes you feel like you need to pee. It's just a fancier name. This is controlled by your nervous system. On the autonomic side, we are controlling the internal sphincter with the smooth muscle, and the somatic side controls the external sphincter with the skeletal muscle. That's why the internal one is involuntary and the external sphincter is voluntary, because two sides of the nervous system are controlling them separately. The nerves involved are the hypogastric, the pelvic, and the pudendal. These three are going to help innervate everything and allow communication between the nervous system and all of the bladder and the urethra. So here's our nerves and where they inundate, right, or they inundate, where they innervate. So they come down, here's the pudendal, right, coming around. We see that it's innervating some other things as well, right, like in this case we're looking at the female side, so we're seeing it innervate some of the vulva. But we see it also innervate that sphincter right here. So this is going to be the one, this is going to be like the external one, right? Right there. Now, why is this important, and what else is going on here? The reflexes, this reflex is going to be in response to what we call like a stretch reflex, or a stretch receptors, I should say. These stretch receptors are going to send the signal up to the nervous system, to the central nervous system, that the bladder is full. And when that occurs, then we can send the signal out to relax the internal sphincter and relax the external sphincter. Now, if someone does not have this reflex, there's something wrong. And I know I'm a cat lady, but this actually applies here. I have a cat who does not necessarily experience the micturition reflex. Because of that, he retains urine. He does not have the sensation that his bladder is full. And so he needs reminders to use the restroom. You have to pick him up and put him into the litter box, and then he'll go, oh, wow, oh yeah, I should probably do that. I haven't done that in a while. And he also needs a little help manually by actually reaching up, grabbing his bladder, and squeezing it so that you forcefully pass urine through those sphincters. And so someone who has damage to the nerves here or something, we're not sure, like in the case of my cat, we don't actually know what happened. But in some people where this micturition reflex is gone, they will not feel the need to urinate, or maybe if they feel it, they won't be able to respond. They won't be able to cause micturition to occur. They won't be able to urinate on their own. And so in some cases, that can be relieved by manual expression. There's a whole list of things that can be done, but like in the case of our cat, he literally gets his bladder squeezed to allow the urine to pass through the sphincter without this reflex occurring in him.